Morning, girls. So today what we're doing is basically what we did last lesson, but we're combining everything where we're sketching trigonometric graphs. All right. So two main things today. We'll be learning how to sketch trigonometric functions, but the main questions that I want to explain is actually getting the description into the equation, which can be a bit tricky. Alright, so honestly, these two examples are like a revision to what you've done last exercise. So you can skip over this if you're confident with sketching these type of graphs. But if you're not, and I made a few silly errors when I did this yesterday, so, if you want to watch out for those, watch it. But if not, just skip on to when I do these other questions. Alright, so these are just like a step of notes on what I like to do when I sketch combination of trigonometric function. And these three properties is something that you're definitely going to need when you find the equation from a description. So make sure you keep these in mind because I forgot to keep them yesterday. Alright, so let's sketch that. The first thing when you have like a whole bunch of things combined, the first thing is to always just label the amplitude, which is your vertical dilation. So that's the easy part. So I'll just label that here, 4, you got minus 4. And I'm going to start off by sketching this, okay, without the shifting yet. In order to sketch that, I obviously need to know what the period is. So let's find out the period. And as we learned, the period formula is 2 pi over n. In this case, 2 pi over a half. So that's 4 pi. So one sine graph ends at 4 pi. So let's sketch that. All right, so it's 4 pi there. And then obviously halfway through that is 2 pi. All right. Now, from here, obviously, now I need to shift it up by 1. So let's take every one of these points and shift it up by 1. So obviously, if it's 0, it's going to go up by 1. So I'm just going to take, that's my new point there. At 4, it's going to become 5. All right. At minus 4, it becomes minus 3. So I'll just put that here. That point goes up to 1 as well. So let's sketch it out. Right, so you got something like that, which is your graph of that. But remember, keep in mind they want it up to 2 pi, so you got to erase everything up until 2 pi over there. So then your graph would look something like this as an end result. It will look something like this, okay? Notice how I rubbed up this part as well, because that's where 2 pi is. So like you don't want to show the bit. You don't want to show this bit because that's going over 2 pi. So that's a little slight mistake I made. So you want to be accurate as possible and like erase it to that exact point. All right, this one, horizontal translation. It's not bad, but when it comes to horizontally transforming or shifting it, it can be a bit fiddly. So you need to be accurate with this. So once again, let's just draw 3 cos graph. So start off by just drawing y equals to 3 cos x. All right, so that's the amplitude. So, and obviously because there's no number in front of x, that means it ends at 2 pi. Now, because we're now going to shift everything by pi over 4 units to the right, obviously, because it's positive, we want to label as many x-intercepts as possible, so x values. So that's pi then. That's 3 pi over 2. That would be pi over 2. Because we're dealing with pi over 4, you want to label like pi over 4 as well. So in between these two. Yeah, that's good enough for me to move on now. All right, so that means that 0 point goes now shifted to pi over 4 point here. Okay, now from pi over 2, so from pi over 2, if I do pi over 2 plus pi over 4, that does not get shifted to pi. That's the trap that a lot of students may fall into. 0.75 pi. So this is 1 pi. So 0.75 pi, that means will be about there. So that's my new point there. Let's do the same thing at the point at pi. So if I do pi plus pi over 4, I get, that's just 1 plus 0.25. So that's 1.25 pi. So from 1 pi, this, by the way, is 1.5 pi. So this would be just like before 1.5. So this point is going to go roughly like halfway through, about there. So that would be like your 1.25 pi. So what I'm trying to say is you've got to be really accurate with this, all right? Let's do the same thing here. So that plus, that's 1.75 pi, so that's 2 pi. So it'll be like, roughly like there, somewhere about there. Yep. So let's just sketch the pattern now with the dots that I have. All right, so we got about there, and then just continue the graph up until 2 pi, and from here as well, obviously, if you just follow the pattern, it's going to look something like that. All right, so just make sure you're very accurate when it comes to horizontal translation, because yeah, you can get it wrong. All right, let's have a look at example 9b. So find the equation of a cosine function. So it says cosine function, so I'm going to start off by writing y equals to cos x, like that. Okay, he has an amplitude of 5, so that means the number 5 is in front. Period is 4 pi, so remember the formula for period is 2 pi over n, so they're saying the period is 4 pi. So let's figure out what n is. So if I multiply that over, that's 4 pi n, so n is equal to 2 pi over 4 pi, so n is equal to a half. So that's basically the number I'm going to put in here. And then center minus 2, remember that's vertical dilation, so you're just putting like minus 2 at the end. And phase of 2 units to the left. So that means you're getting the graph and you're shifting it 2 units to the left. But this is the part I want you to be careful. You need to put a bracket right outside of x. And then if you're moving 2 units to the left, you're writing plus 2 as we learned. Put a bracket like that. So this is actually technically, or you want to write it like this with bigger brackets like that. That's your final correct answer. All right? You don't want to write this. So compared to this, okay, that's incorrect. Okay, and the way you can tell if it's incorrect is if you actually solved that. So if I make half x plus 2 equals to 0, that's half x equals to minus 2, that's x equals to minus 4. That's incorrect. That's not what I want. In the description, it says 2 units to the left. I got 4 units to the left here. But as here, if you can have a look, if I expand this out, that's half x plus 1, make it equal to 0. And if you solve that, as you can see, you'll get x equals to minus 2. So it's very important you put the bracket right outside of x. Don't include it like as a 1 bracket with a horizontal dilation in front. Right, so that's one point I want to point out. Now let's have a look at question 3b. Okay, so find the equation of the transform function. We've got y equals to cos x again. 3b, reflected in the x-axis means the graph gets flipped upside down, remember? So that just means you're putting a minus in front. Reflected in the y-axis, remember that means you're putting a minus in front of the x, and usually you put a bracket around it. Now this is the part where I want to stop. Girls, when you have a negative x in cos, it's the same thing as not having x as well, okay? That's one of the properties if you forgot. So right now, I can rewrite this as negative cos just x, okay? It is important you use those properties. So once you've done that, let's have a look at the next part. Translated 5 units down, so that's just minus 5. And then pi units to the left. So that just means inside the bracket with the x, pi units to the left means you're putting plus pi. All right, so that would be our final answer. Find the equation of the transform function of y equals to sine x this time. It's vertically dilated with scale factor of 5, so that means the amplitude is 5. Horizontally dilated with a scale factor of a third. So remember, if it's horizontal, you put the reciprocal of that, which is 1 over 1 over 3 is just 3. So that's the number in front of x. Translated 6 units down, so let's just take away 6. And then 5 units to the left. So remember, you have to put the bracket outside of the x, and then write plus 5. So we have that. Or put a big bracket around that. All right, 6d, we got y equals to sine x again. It says vertical dilation scale factor 4, so that's just 4 in front. A reflection in the y-axis, that means you're going to put minus in front of the x, like that. Okay. Yeah, okay. Before we do that, like whenever you have a negative in front of the x, you always want to stop and think if you can use one of the properties. So for sine, if you have a negative it's like the same thing as you putting a negative out in front. So from here, before we move on, let me write it as negative 4 sine x, okay? It just makes the equation a lot friendlier to work with or add on. So 60, what was it after that? So after the reflection in the y-axis, a horizontal dilation of 3. So that just means I'm going to put reciprocal of that once again, which is a third. And then vertical translation 2 units up, so that's just plus 2 at the end. And a horizontal translation 5 units to the left. So outside of the x bracket, so that'll be plus 5. All right, so once again, you can leave your answer like that, or, you know, you can write it like that. All right, in the answers, it says 4 sine negative a third x plus 5. Okay, you'll notice they're the same thing. Okay, having the negative in front is the same thing as taking it out, and you can see that the same graph if you actually type that out in Desmos and type that out, and you'll see that the same thing. All right, but you normally want to take the negative out if you can. All right, so question 10, equation of the blood pressure is a sine function over time, t, if the maximum blood pressure is 120 and the minimum is 80, with a heart rate of 80 beats per minute, find the equation. With this type of question, girls, I broke it down. So let's find the center, amplitude, and period of that question and then form the equation. In order to get this equation, I think it's actually good to see it graphically what they mean by when they say, first of all, it's all about the blood pressure over time. And it says the maximum blood pressure is 120. So that means like your peak of the graph. So the graph looks like this, and I'll show you why. It's like up in the air. So the amplitude or the peak point is 120 and the minimum is 80. So that means that bottom point is 80. So we need those two informations. And as you can see graphically, that means the center of the graph will be halfway through. And we can calculate that by adding these two. So if I do 120 plus 80, that's 200. Divide by 2, that's 100 here. All right, which means the amplitude is the distance between 120 and 100, which is obviously 20, and that's obviously the same case below. Okay, now this is the tricky part, the period. We need to use the fact that the heart rate of 60 beats per minute. All right, heart rate of 60 beats per minute. I need to clarify something here. Girls, this graph does not represent a heartbeat. Okay, this graph represents the blood pressure. All right, so you need to understand what they're saying by 60 beats per minute is this is the graph of the blood pressure after the 60 beats. All right, so it doesn't mean 60 heartbeats, so like 60 graphs. That's not what it means, because that's what I thought. So this is the blood pressure after the 60 beats. And how long did it take to get that 60 beats? It says 1 minute. So that's how I think the question is meant to be interpreted. So in order to find the period, as we can see, we have one graph in 1 minute. All right. So now instead of 1 minute though, what the answer seems to have done is they've put 60 seconds instead of minutes. So if you work this out, so it's pi over 30. So your final equation basically is y equals to, so the amplitude is 20 sine, that's the period, the number in front of the x in this case is t, and then obviously as you can see it's been shifted up to 100, so that's your equation. All right, so yeah, I just want to clarify, I feel like with this question it should say express the equation with t in seconds, because if it said work it out in minutes, that should have been 1, but this is how they seem to have done the answer. So yeah, I just wanted to kind of clear that out because it was a bit of a tricky question. Okay, so do the same thing for question 9. Okay, girls, that's it from me. If you have any questions, let me know.